Hi, welcome back. So we're at the outline to cover the basic introduction and the use of NumPy package. Now, basically, NumPy, which stands for Numerical Python, is an open source Python library that is used in almost every field of science and engineering. Now, basically, NumPy library contains multidimensional arrays, matrices, data structure, with method to efficiently operate on them. I think we have worked on the concept of creating our own modules and how we create number of those modules, packaging them into one directory we call it package, and then make it available for people just to import. The concept isn't there. You should imagine NumPy is number of modules that are operating on such a structure. And I think if you understand the concept of Python, you will understand the concept of modules, understand the concept of package, then you will understand the concept of NumPy as an external tool. Unfortunately, many people fail to understand the functionality of a package and Python and modules, and then they get hard time to understand how to even utilize external tools or packages such as NumPy. You should be able to understand what is the purpose of the mathematical operation you want to do. Also able to write your own code since you understand the syntax of Python. However, instead of reinventing the wheel, we will find NumPy very useful because many of the work that I need to code, it's already been done. So what I have to do, I just need to import NumPy, and then I start to access those functionalities. So try to take the simple as easy as possible. Now, to start up, you need, of course, to install NumPy. And then once you install, the convention is to import NumPy as something called NP. Now you start to use the keyword NP wherever you like to access or to reach to any function that is inside this package. Now, the next thing maybe we need to talk about, what is actually difference between the Python list, which we've learned about something like that, and the NumPy array. The NumPy array gives you an enormous range of fast and efficient way to create arrays and manipulate them numerically. Now, you can do the same job absolutely using Python list on your own. If you want to deal with NumPy, you have first of all to understand we need to let NumPy package understand the structure. So this array convert Python list into a structure that NumPy can understand and deal with. And once actually you convert the Python list into an NumPy array, it means you will have an access to all the operational and the calculation of different kind of mathematical equations using the NumPy package. Because every other package inside NumPy need a certain structure, and that structure has been taken care of by this array. The simplest I would say, this is an X list by Python understanding from homogeneous type. Now NumPy would be an X of NP type, would be something like this. By taking the NP modules and we reach out to the array function to pass to it a list, and this list will be the X list, which is the Python list. Now if I want to print, you would get back the result like so. Now before I close down on that, I want you to finally understand something called 1D array, 2D array, ND array, vector, and matrix. These are the most popular terminology you might run into. Now, NumPy ND array, which is usually is written any reference, ND array, something like that. It is a class in general, and it's used to represent both matrices and vectors. If you understand what is vector from mathematical perspective and matrix, it becomes so easy to understand how this package structured them. Now, vector from the perspective of NumPy, it is just an array. It's a list in the language of Python with a single dimension. Now, when I say dimension, I think the idea has to be clear. XMP, it has one dimension. Now, there is no difference. This could be a row vector, or could be a column vector from mathematical perspective. But what is matrix refers to an array with two dimensions. If I would have to come here, Python list, inside this list, there's one list and there is another list. Run this one more time. This is the way represented from Python perspective, but here from NumPy perspective, it becomes a matrix. And this matrix has two rows. This is one row, the second row, and it has 4 columns, as you could see in here. Now, if I would have to do this, missing one of those dimensions here, columns in here, and I ran this. Now, from Python perspective, it didn't really care because all of it is just a list, big list, and inside it there are two lists. But from the perspective of NumPy, you could see things has changed. It sent me a warning saying now creating ND array from a rigid means you don't have the same exact number of variables for each list. Now, if I would have to make a 3-dimension, once again, I would get all this matrix into a bigger one. Run this, I will get exactly what you expect. This is called a tensor. So we've seen the 1D, we've seen the 2D, whatever it's called, the ND array now. Concept of vector as a row or as a column doesn't matter. And we saw that the concept of matrix, it's the 2D. However, we put much more than that. It's the ND, it become actually what's called the tensor, which is the last case of what we've seen in here. In the next one, we're going to be looking how actually to create a basic array, and we start to operate on them. I'll see you then.